Yeah, now I'm inviting Mr. Nasir Ahmed for presenting his paper number 188. Thank you.
Good afternoon. Today's session chair. Uh, anyway, it's coming, I think. So I am actually Nasir Ahmed. So I'm just working in Bangladesh Atomic Energy Commission, and my position is the member engineering. And though the name actually, the Atomic Energy Commission, when you just see the name, but something you will be a little bit confused with the water resources. So what we actually do in the water resources in this organization. And this is not the conventional work we just do. Mostly we just work, whatever the work we just do, we actually incorporate or include. This is nuclear technology or nuclear techniques. So this nuclear techniques is the state of the art. So when we are just talking about the fourth industrial revolution, and as we know, this is in the today is the first actually inauguration time. Our state minister, and he just highlighted about the fourth industrial revolution. What should be the goal, and what should be the technology? What is the purpose of the, and why we should going for that actually fourth industrial revolution, and what should be our focus, and what sort of technology we will get in touch, or we will just start for. So in that context, actually, where if I say this is the isotope techniques, this is state of the art technology. Solution of the water resource, any problem, and the hydrological problem, geohydrological problem, even the ecosystem. So this technology might have helped in the sustainable development goal of the, particularly the water resources. There are other goals also in the SDG. So this is my introduction. So I'm just now. So what are the takeaways? Or the major decisions come out from the IPCC, intergovernmental, the panel of the climate change. So some of the important things are focused. The water resource in most of the cases, not only in the Bangladesh. In Bangladesh, the water stress is very acute. Resources. And even though other factor is the climate change, is putting also, additional one of the factor is imposing the water stress also. So actually the government is actually approaching for the SDG. There are so many, this is the 17 goals. The one important goal is goal 6. And government is committed to target by 2021, and we have already achieved a lot. And as I worked with this particular groundwater and surface water also, the goal 6 means the clean water and sanitation. And this achievement, how much achieved we have, and I think all of us know, and particularly in the conventional system, what we did in the water resource management. And now I will just show in some of the next slides what sort of actually the my applications we just did, and what are the opportunities if we just focus, if we just approach for the fourth industrial revolution. And so this is sustainable development, and this is that our Prime Minister, when he attended the Water Summit, and she just said the Bangladesh actually is committed to provide the saving water to all sectors, particularly in the rural area, and also the sanitation, which means the sustainable goal. The goal 6 of the SDG. And she also said that the Bangladesh government also acknowledged the contribution that was come up from the Budapest Water Summit, which government actually mostly focused on the SDG, the water-related SDG. So here I'm just coming out. I'm coming in my main work on isotope techniques and hydrology. So what are the isotope? What is called the hydrology? Hydrology, we know the hydrological science it's a science which actually deals with the water, in the surface water and groundwater, where the water even in the hydrological cycle it means all. So when I just use the isotope hydrology, what does it mean? Actually, isotope hydrology, this is there is a 2 type of isotope are being used. There is stabilized and radioactive isotope. That are environmental. That is not the artificial. In environment, we have the isotopes. So these are the basic isotopes, actually, the hydrogen, carbon, and tritium. And here, actually, these are most of the basic. Mostly the water, actually, when you, an H2O, that water, actually, there is the compositions and how we just actually work with this composition. So when we just talk about the isotope, actually, there is atoms, and in atoms there is a nucleus. In the nucleus, we know the proton and neutron, and surrounding the proton there is the electron charge. So proton is a positive charge, and neutron, this is totally neutron. So only the difference of the neutron. So it becomes the mass differences in the same element. Just if you look at the hydrogen has the three type of the mass difference. The first one is the one proton. There's no any neutron. So this is called the protium, the most abundant actually in the water cycle, everywhere actually. And second one is the deuterium. So deuterium is we call the heavier isotope actually. So it contains only the one neutron. So there's a mass change. So how much mass change you can see when we talk about the isotopes of oxygen. So there is a very simple calculation. So the tritium actually, this becomes actually the radioactive isotopes. So there's a half-life. When you talk about the radioactivity, it's a half-life. Half-life is 12.73 years. And it contains the two neutrons. Because of the neutron changes, there's a mass difference. And this mass difference we use for the water resource, a different identification, water age determination. And similarly, the isotopes from the oxygen. You see oxygen 16, oxygen 17, and oxygen 18. So there is a due to only the neutron, changes of the neutron, the element and the oxygen. So we call it due to the mass difference, we call it the isotopes. Oxygen 16 is one isotope, oxygen 7 and oxygen 18. So this actually, this is the basic things we just use in isotope technique. What we just do is we use the water resources and we trace. So this is a good tracer for the water movement and the water recharge, even the contamination use. So these actually isotopes we just always designate as a fingerprint. What do you mean the fingerprint? Fingerprint just like a detective, the police detective when any crimes occurs. So everywhere there is the prints of the finger. So similarly, the isotope actually is being used as a fingerprint, and how it is used. So if you just look at the right one of the water fingerprints. So I'm just coming on the next slide, then you can understand. So here are the applications. Most of the applications we just use. Here you see this is a lot of isotopes here: oxygen, hydrogen, carbon. The most basic actually in Bangladesh we are using oxygen and hydrogen and carbon only. The other actually helium, argon, chlorine. These are the noble gas. But this is not the noble gas. These are directly the water actually. And what are the applications? Recharge areas and rates calculation, water origin, the finding out and mixing the flow water, and the origin of the contamination, saline water intrusions, climate change issues, and the water budget. So the water interactions and the surface water, groundwater, actually connectivity in order to find out. There's all the interest. And other than this, there are other applications also, but we are not going to that applications. This is called the paleoclimate, the sedimentology study. There are so many other studies actually. So why we use the water isotope techniques? Actually, this is the very cost-effective technique. So which can give you the unique information, which we can get it from the conventional system. Just like the water is. I will take about the residence time of the water that we cannot get in from the conventional system. So in Bengal, we call the panir boyos. Now how we can get it? So water age is very important tools for the water resource management. So this sort of thing, this rapid understanding of the isotope hydrology system, and even the atmosphere. If you want to know about that, the climate, processes, circulation processes to know that. So that isotope is being used abundantly. In our country, we have also used that. Actually, one thing is that important that here I've shown some small applications here. The isotope techniques, scientists can find out this is very basic groundwater is and the water pollutions to know the movement of the water. So we can see this explicit solution to water and trace the water balance. And this is how we just actually define this. Is there any unit? So this is defined with the delta notation. So that delta actually used for the relative with what? The reference is being used the B small, Vienna Standard Mean Ocean Water. And Vienna, actually, why we use the Vienna? Vienna, actually, they are IEA headquarter. So they are actually collecting the water. Actually, this is ocean water, and they actually give us the reference samples to all over the world. The laboratories supply. And this thing you see, these are related in a sample, and this is a sample and a standard. So it's a relative to the standard. We use the standard, means this is the standard. Vienna is the V small. With this actually relative value, we can get the information. Just like we can say the positive value and negative value. When we say the positive value, it's called the enriched, and when the negative value is called the depleted value. And here you see this oxygen 16. Oxygen 16, oxygen 7, and oxygen 18. So this is mostly abundant 99% in the atmosphere. Oxygen 16. This is more the lighter isotope. When you go to the heavier isotope, so this is called the oxygen 18. So this is this when the precipitation occurs, it goes down, and when the evaporation occurs, then the oxygen 16s go up. And mostly there are totally 9 species of the water. Most abundantly, this is being used and calculated in the machine. That is the only the composition is H2O16, D is deuterium. So this is the mass actually. D 2 mass hydrogen. So 2 and 1 is 3 mass. So this is hydrogen and oxygen 16. This is hydrogen and oxygen 18. So this is actually how we just define. This is we just express, and we just define the water actually, and through the Craig water line. So this is the metric water line. And here when we just water samples, and here when this is a very generalized, very typical like diagram. So this actually the point actually we designate as an ocean water. So this is the estuarine, or there is some mixing with the seawater and the groundwater here. So there is all these groundwaters actually fall here. When there's a water samples here, we can see that the evaporation is occurs. It tells us this sort of information. So total actually absolutely this graph tells us a very big unique information. So this is the one important thing. So the phase changes. When the water actually comes from the ocean, river, it goes again just like a hydrological cycle. So there's a lot of phase changes occur. So due to this phase changes means, this evaporation, condensation, the water, the vapor transportation. So here we just look at that. So this is one of the typical diagram, and the similar effect we're getting in our case. So from here, even the saline nutrition is going on not, and even the water actually evaporation, the lighter isotope go first up, and the heavier isotope goes down. So there is called the fractionation occurs. There is some effect occurs actually, continental effect. And even you see there's a recycling of the vapor, which sometimes contribute to our water resources. One of the good fingerprint also. Even in the climate change, this recycling of the vapor. And recycling means this is from the evapotranspiration, and even from the lake water actually evaporates. So this sometimes contribute to the total actually when an isotope is going to change in the continental way, it contributes also. It also adds some changes to the fingerprint. So this is the key findings of some of the applications. I'm just going very closely, quickly here. So this I already, ultimately what actually happens actually when the samples we collected, and we actually just where the water, we want to know the origin of the water and the age of the water. So it actually helps the policy makers how the water to be protected. So this ultimately goes to the conservation policy. So here is the laboratory. In the Sabar, we have the very good laboratory actually. The stabilizer measure of the laser machine. This is the carbon. This is this is called the liquidation counter. These are tritium measurement. So tritium enrichment unit systems here. These are the chemical laboratory and the field systems laboratory also. But there is only the basic things are here. So this is one in one project here. What we just did here actually very quickly. I'm going here. This is actually we just classify the water actually type 1, type 2, type 3, and type 4 water. So this actually from the arsenic remediation, this is called arsenic mitigation project actually. And what just did actually here, if you just look at one of the very important thing, this is actually hydrogeological, very typical actually hydrogeological cross sections or lithological system. So this first we can see, if we just look at this thing, the first one is a first aquifer. This is one of the shallow aquifers, 700 meter. And then the second one is called the intermediate aquifer, and third one is the aquifer. So with this, using this aquifers, the sample collection from this aquifers, provided we must have the single stainer. We shouldn't have the multiple stainer. Otherwise, we won't get any good result. The most of the cases when we just go for the sampling, in the DPH as well, they have the single stainer, as we know that. But only for the in the Dhaka wells, there's the multiple stainer, particularly in the Dhaka, our Dhaka washers well. So we are getting aware of that. We just took the sample, but just we compare how the results come at, and even the tritium or carbon, not the carbon 14, particularly tritium. So if it's a deep aquifer, we get the tritium is greater than 1. So we definitely we can say there's a mixing that's going on here. So actually now, if you just look at this type 1 water actually say type 1 and type 2 water, actually you see this is there's arsenic contaminated here. So that water, that continuous recharge is coming. But here actually the water continues, sometimes not, sometimes there's a leak, it's called the leaking due to the pumping effect of some of the actuator is getting loose. So there is a chance of water to go get intruded in the second aquifer. And in our case in Bangladesh, we have this very good actuator, but in some cases we don't have any acute. So this is the sometimes what we have. What happens here? Here we get in the second aquifer, we get the sometimes when we measure the age of the water, it is 100 years or 2,000 years old water, and even the tritium value which indicates that there is some mixing occurs here. But when you just go for the more deeper, the more than 300 meter or 300 meter like. So we get the water, actually, the age of the water becomes more than 20,000 years old water. So it means there is no recharge at all in the vertical recharge. So this tells us one of the very good information, the water, the fresh water might be here. So there is, we should be aware of the groundwater mining. So this message actually helps us, Bangladesh Groundwater Task Force and they accepted this model actually. And they were ultimately DPHE and other organizations, they based on this information, they started thinking on the sustainable use of the groundwater resources, and they actually make abundant all the shallow aquifers mostly, because that cannot be used for the drinking purposes, only the deep aquifers. So that's why they started doing the community water supply. So this is the information that was very positively used in our water sector, particularly the groundwater sector. Here you just look at this thing here. So if you just look, this is the Craig water line. This is called the Craig water line, and here all the samples are here, and what information we get from here. So this is what happened here. So when you're in the middle part, so recharge from the present day rain, and it gives the information like the water actually comes from the isotope value. Yeah, the groundwater recharge mostly from the rain and the flood waters. Here you see the rate. The rate is deep wells and shallow wells. This one, and again, if we just look at this thing. So this water actually the shallow wells. But what happens here? So it is -7 and -8. So most of the waters in our river water is -7, -8. So in this case, we can say, so this water is very much, this shallow aquifer in Lokipur is mostly connected with the river water. And the next we just look at this thing, the Burit Chor. So there is a chance, is mostly in the most enriched part. So there is a chance there is a mixing with the seawater. So in order to find out if it is truly mixing or not with the seawater, so then again we have to go for the carbon, and carbon and chloride. So I'm just coming on the next slide. These are some of the posters that was published in IEA, and they actually based on our results. This is an international that was highly recognized our value. So these another projects work in the Chapai Nobgons. Here we just look at the things. The arsenic is in the marine area, and this is in a metropolitan arsenic affected area. When we just look at the insides of the stabilizer and using the tritium, what happens here? So there is a demarcation of two water actually, because if you just look at this thing, there is the water barrier. Water barrier, and there is some small fault line. So geology is one of the important part when I'm just working with the groundwater actually. So this is the part in the central part of the Chapai Nogans, the most city area. So here mostly arsenic affected. When you just take the values like this, so mostly the tritium is very high, but in some part of the tritium is very low. It means it should be some fresh water is there, but there is some migration of the water actually from the marine actually. The marine means it's uplifted plasticine. It's called the plasticine terrace, or the uplifted plasticine, the pleioplasticine or plasticine. So this is a very old sediment is there, but nevertheless, there is some water might be getting intruded in this part, very small. When there is a fault line, the water is not directly going that. From there is some circulation is going there. So when we just look at this thing in the right part, you see, so there's this water actually we say this is a Holocene and this is the Pleistocene aquifer. The Holocene means the recent water, and the Pleistocene is a very old water is there. So this is the marine part. So this isotope gives us the one of very good information, but that's very helpful for the water resource management. In other words, used to work in a, this is, we did it in a Bagheera, and we just classified a type 1 and type 2 water. And here you just look at this thing very quickly. I'm just going here, the seawater. When there's a pipette diagram, this is the sodium, very high sodium chloride. The water actually is very high, even if there's a shallow water, and even though there is a deep water there, particularly in type 2, deep water contains the saline. Why? Is it a salinity intrusion? So now I'm coming there. Here you just look at this thing here. So there is no halide dissolution. Only the mixing and evaporation is going on. This means there is no directly, even the we just look at the halide line and even the dissolution line, the water directly, not deep aquifer, not come in the same line. They're deviated. So it means there is no any deep water actually connected with this, connected with the seawater intrusion. So it means that there is some salt evaporation is going on here. So again, we just look at this thing, even this figure actually tells us this, it is not the mixing line with the rainwater and the seawater. So this hypothetical line, mixing line, so this is mostly deviated from that line, you see. So even the shallow aquifer is not particularly, get connected, just a little bit. So here that was the World Bank, they actually installed very deep water actually in South Gambuz area, and we just did, and there's no saline, there's very fresh water in a very close boundary. You see there's a fresh water and there is some few saline water. So this is the isotope tells us this information. So how are you getting aware of the water resource management? So even this is one of the tritium and chloride. So this is actually tritium is when it is getting higher. It means so there is a chance of getting some tendency of the decreasing of the salinity, increasing of the salinity. Sorry. So anyway, and this another work we did in the Sylhet area. In Sylhet area, there's no any salinity problem, but there's a classification of the water actually, and this water actually we tell there is some connectivity with the Surma river with our shallow aquifers. But there is a type 1 and type 2 water. Type 1 water where there's mostly the deep water, there's a very fresh water and old water. But when they're coming with the depleted water, so this is the shallow water, shallow independent water. So it means the water age is less, nearly 2,000, 3,000 years old water actually. So this is actually a special diagram actually. How this is when we just look at this thing in Sylhet area, there is a when we just diagram the make it in any water flow means there is a very gradual. When we just the potential line, there is a chance the water actually gets gradually to the directly to the according to the slope gradient. But here what happens is due to the lot of lineaments are here, even the fault lines here. So this is the carbon-14 mapping. Through this carbon-14 mapping, we just confirm that. So this actually the water direction is different. So this actually confirms that. So even the water actually policymakers, they will be aware of that. Water is not coming directly in the similar, or there is no any gravity flow is here like that only in the slope.
Excuse me, Mr. Nasir, we can go directly to the conclusion of your presentation.
So this similar situation is happening here as a similar situation. Another project work we have happened here. So these have already informed that. So there is a very small. I will just focus on very quickly. So actually isotope actually is used also the climate proxies, like a temperature, rainfall, relative humidity, precipitation, and the wind speed here. So these are global. We actually Bangladesh is connected with the global network, GNEP. And GNEP actually, this is you see this is the bomb tritium. The bomb tritium actually they carry the water, particularly the water from and we also give the tritium water to the also. And here in the one is Canada and this is one of the New Zealand. So almost in 1960 when there was a bomb testing, the Russia and America, USA, they used the bomb testing. There was a high tritium in the atmosphere, just particularly in the North Pole, and now it is already coming to the background level. And here the seasonal and geographical variations of oxygen isotopes. So this actually isotopes are used for the climate variability and climate information, very useful information. And we are also here actually in collaboration with the Bangladesh Meteorology Department. We are taking the samples and their data, and we are using the satellite data. So and this is the Palmex rainfall we use in order to prevent the sample evaporation. It's very special type the water sample collection and water sample collector actually. So here, actually the water cycle and what is the effect, the precipitation amount effect, and we from using this stable isotope, we actually use this thing, And this is the basic one of the important. Our question is whether the interseasonal actually oscillation, which is actually contribute to our actual isotope variations in our precipitation or not. So we actually look at all these things, and definitely. And here you see this is just only 1 minute. I'm just this thing. So water actually in the sea. This is the band, actually the black band. This is called the our monsoon. This is called the monsoon. So water actually enriched water, when there is less water and the evaporation is very high, then actually usually this very high enriched water, and here actually depleted water when there is a post monsoon time. Anyway, so this is our amount effect actually from this.
Can you please go to your last slide so that
okay.
we can summarize the presentation and
Anyway,
your
so this is
paper?
Key findings.
Yes.
Actually, values of the oxygenating are more depleted during rainy season, while enriched values are associated in the winter and summer and the monsoon. So climate, actually, our GIS climate, all the values are being used as the proxies for the oxygenating. And during rainy season, actually interseasonal variability, what I told you before, the interseasonal variability is Bangladesh is very prominent. And actually we have the very convective. This is air circulation in the Bay of Bengal. So this information is mostly remarkable. I mean, depletions occurred in the Bay of Bengal, and it occurs during the intense convective activity. This happens actually. And here the isotope variability in Bangladesh is controlled by the large scale convective activity, local rainfall amount, and air temperature rainfall amount have the less influence on the stable isotope precipitation. Mostly the controls actually, the moisture sources, different moisture from maybe from the Indian Ocean, maybe from the Bay of Bengal, from other sources actually. So these are the actual take-home messages actually, which is the conclusion main actually. The present findings indicate for the groundwater actually, upper 2.1, the regional sampling actually we should do and more. And from the seasonal sampling, which in order to just find out the particularly the sabering water to know, but and even we should do the mapping also, which is very important. And depleted aquifers have found the free of arsenic, but in some cases salinity is a constraint for the drinking water also. So this sort of actually basis gives us and stabilize now this is the climate purpose. Stabilizing precipitation shows the capacity and advantage in revealing the atmospheric processes. And the next actually I can tell this is the isotope technique and hydrology provides the precise, the scientific and low-cost information to help guide decision about the managed water supply. So thank you very much.
Thank you so much for your nice presentation, and I have learned a lot. My background is transportation engineering and the specialization on traffic safety. Even if I have few comments, but let's take comments from, as we don't have any presenter left, so we can go directly go for the Q&A sessions. So do you have any other question to any of the presenters? Okay, I have some question if you never mind. Yeah. Yes, please.
My background is civil engineering.
Okay. Yeah.
I also previously I worked with structures and a lot of things. Even I work Jamuna Breeze and Pakshi. And I have some experience when I worked with when I was in Bangladesh Consulting Limited, BCL. Yeah. Actually, I have some experience in working with the steel structures and. But actually, I want to know this is steel is very important, but particularly in other country in the world. And when I work with the Malaysian company, mostly they are very much familiar with. In Bangladesh, actually, what are the causes actually? Mostly the people are very much feel comfortable to use only the RCC. So they are not going from the approach, but it is from the, as we know that the steel is durability from the point of view is maybe is more important. Even one thing is that when I work in the Malaysian company, I see that this is called composite structures. So do you have any give us an idea on that? And composite means they're parallelly they are using the steel and also the concrete. So in Bangladesh, what are the constraints actually?
Okay. Okay, thank you very much. Your nice question. Actually, I completed master's from Malaysia, and I complete my PhD from Hong Kong University. And in 2002, I complete master's in Malaysia University, Putra, Malaysia. My master's research also on steel structure. So that time, last time profile steel sheet. Now we call Jalalabad Dheutin or like this. First, it was innovated in Australia and Singapore, Hong Kong, Malaysia, Brunei. So that region, they are export this steel structure, and they use the profile steel sheet. And now in all most of the advanced construction, they are using the steel structure, because steel structure is cost effective. Initial cost is high, but in cost long-term effect, steel structure is more effective, because already I already show my slide. China already completed one stainless steel bridge, not only steel. This is also stainless steel bridge, 55 kilometers. Our Padma bridge 6.8 kilometer, our Jamuna bridge 4.8 kilometer. But China already done 55 kilometers. That means one district to other district, more than that. They also use the stainless steel. So and they say 120 years without maintenance, they can maintain this steel bridge. In our context, in our country, in my observation, now already started using the steel structure like Padma bridge, railway bridge. Last 1.5 months before I visited our dual gauge Bangabandhu Jamuna railway bridge, steel bridge, Trans bridge, and some steel building now are going in Bangladesh constructed. Last few months before, I also in Ruet Department of Civil Engineering vetting one of the eye hospital in Jashore, a fully steel building. So and now factory building, some are constructed in steel building. In constraint in our country, in Bangladesh, one thing is initial cost is still comparatively higher. It is the one constraint in, I think, and most of the people still are not motivated to using the steel. So we need to motivate people to using the steel for a better future and better construction. Thank you.
I have a few more questions to Mr. Nasir Ahmed. What was your sample size? And sometimes I saw that you collected the ocean water, and did you collect the river water, and how much?
Very much for the question. So for the different isotopes, actually the sample volume is different. For the particular the stable isotope, only the 50 ml water is being collected, very small. But we have to very careful in collecting. Isotope sample collection is very careful. It is not in a simple way. So there is a protocol. So we use the IEA protocol or United States Geological USGS protocol. So using this protocol actually, and mostly the same things are leading. Particularly the bottle should be is not the plastic bottle. It should be HDPE. So there shouldn't be, there must be avoided that the leakage from the bottle actually, and that should be airtight. Even the sample should be so. Then there is some protocol actually, and there's a 50 ml of water actually for the stable isotope. For the tritium, we take the 500 ml water, and particularly the carbon. Carbon actually is not the straightforward sample collection. It is called from the carbonate precipitation. We actually some in the sample. Oh, এটা কোথায় গেল আমার এটা?
Okay, no problem.
So,
I also
একটু আমি একটু দেখাই এটা একটু দেখাই. In the carbon sample collection, it's not the straightforward the sample collection. The carbon sample collection is here. You just look at this thing. So this one. So this is the carbon. There is a precipitator. We use that. So there is some system. We use some chemicals here. The water actually, the 6-liter water actually, we just first poured, and there is a precipitation. We just do and carbonate. So see, this is strontium carbonate. We actually collect. And that strontium carbonate was used, taken to the laboratory. And that strontium carbonate we collect mostly 1 liter, the 1 liter.
So did you collect only the arsenic-free water?
Yeah. No, arsenic free or arsenic actually is the issues comes later on actually. First we want to know whether the aquifer or the well is in shallow aquifer or the deep aquifer.
That's
If it is a shallow aquifer, we'll never go for the carbon. First, we must identify the tritium. The tritium actually tells us whether the value is less than 1 or greater than 1. If it is less than 1,
that means arsenic free water, you came it later on, right? Initially you collected the water generally.
The local people or the DPH when just tells us they just deep aquifer actually.
Because your target was to protect the water. So
not protect water is not our issue. Our actually find out the acid in the water or carrot in the water. Actually protect me. This is the policymakers, particularly like the DPH, those who are the stakeholders and the end user, and they are the management policymakers. We are not we are not our side.
No, but you are suggesting
we are not policymakers. We actually do only the particular assessment and characterizing. The sort of thing we just do, and interpretation of the data, and that's this sort of information, which is very actually nuclear techniques. You can say this is the advanced technology. This sort of information we just try to give them, the stakeholders.
And another thing I saw that you use the VSMOW standard. So which standard is only for the ocean, but you also use the water, river water. So how you use this ocean standard to the river water? I'm a little bit confused. I'm sorry. I'm asking
no problem. This is very interesting question. Actually, this is what happens actually. So when you just look at this thing, oh, sorry, it's not the slide, the upper slide. I'm just very quickly, I will say you this thing. So, yeah. So this actually the relative value to the standard, and standard actually, this is for stable isotope. So this is the universal. And this is
yes, sir, water, I got
that is the water actually. You see that actually here you see this is oxygenating is equal to 0. So though sometimes we get a little bit higher means ocean always it remains is oxygenating starting point is 0. And when you take the ocean water and we just take the water, and when we get the value like this, and that value actually sometimes comes here. So it means it is the ocean water. If it comes here, then it means there is some estuarine effect. So there is some river or ocean is mixing here.
Okay.
So this is very interesting.
I got your comment on that, and it is satisfactory that you use the relative value for the river water. I have last question is you told that this technique is cost-effective techniques, but I didn't see any comparison. I mean, the other materials, if you could show it, it could be more acceptable to us, understandable to us. Sorry.
This is actually, if I just go on that slide actually, and very quickly, I will just say this thing.
I mean, which material you checked? How you find out that this is cost-effective?
This is actually what we are saying. This is cost-effective means when what we measure the actually recharge condition from the any conventional technique. You cannot measure the source of the origin of the water. You cannot measure this thing. Only the isotope can see this, because this is a fingerprint. So this fingerprint actually tells us only this sort of actually information. This so this is the thing. So this is when the water actually isotopes, when it's going and went to the whole cycle, it actually wherever it goes, so it due to the phase changes, and there is some kinetic fractionation called or equilibrium fractionation. So due to that fractionation, every phase changes, it gives some value which is very nearest to some values. I mean, so we can say from this actually typical value compared with this thing. So we can say that there is the recycling of the water is getting occurred, or there is the lake water actually, or groundwater, there is interconnectivity is going on there.
Okay, thank you so much, sir. Thank you so much. I have few more questions to Professor Dr. S.N. Jaharul Islam. Sir, I saw your presentation was actually you wanted to mix CFRP to strengthen the stainless steel, right, sir?
Yes.
Sir, I saw you did comparison with the aluminum and stainless steel and mild steel tabular sections. If you could just one comment is that your title, if you could directly tell that the effectiveness of the CFRP to the aluminum only. All right, sir.
Yeah,
Just you don't need. Do you think you needed to mention the stainless steel and because you are comparing with the other two,
Yeah.
right, sir? Another thing is, sir, I didn't see any statistical significance of the. Did you try to find out the significance of the aluminum material with the when you compare to
In our,
Yes, sir.
okay, thank you.
And also, sir, sir, I'm telling all my question and then you can please. The thing is, what was your sample size? It was, is it the, I saw that six sample you used. Is it, sir, I think you could take more.
Oh, yeah.
So why didn't you take more sample
Yeah,
size?
actually, I give only a few sample because we already run more than 200 sample. But a conference paper is very limited,
Okay,
and presentation slide is very
Yes, sir.
limited. So I saw
Okay.
very few slide and few specimen. And another one is the sample size. You say very short.
Yes, sir.
It is actually North American specification.
Yes, sir.
Provided the guideline for fourth end flange loading, ETF loading, ITF loading,
Yes.
EF loading, and we only present here ITF loading, interior two flange loading. That means depth into 1.5D. So we calculate according to the D, and according this is this is the dimension. Before slide, this is the length of the specimen.
Sir,
We use the
how
North
you-
American specimen.
Sir, how you connect these tools or techniques to the 4IR, sir?
No, it is North American specification. North
That's the
American. This
Mm.
is still it is not included in the code, ASC code or others code, but
Yes.
North American and Australia provided the guidelines to using the web Kipling test for condition: ETF, ITF, EF, IOF. So I only show here, only present here ITF.
That
loading
means
condition.
you use the standard for the North
Standard,
American.
standard.
Sir, is it I mean effective to our countries?
Yeah. If I use a
or
steel
did you
tubular
need
member,
to calibrate?
No, already
Hmm.
calibration means first is the experimental work is the original work, so you can get fine result. And further result, we already numerical model using the abacus model
Yes.
and comparison here. But here is the I present only the part, not
Okay.
only full scale.
That's the reason I could
Yeah.
not get a full view of. Thank you so much, sir. And
Yeah.
thank you so much for all of the presenters.